Why did Java need virtual threads? Now, in order to understand this, let's look at a practical problem. You have an application server which is running a Java-based application. So let's see what happens when we receive a user request. So typical Java application is running inside a JVM, which is running on top of operating system. An operating system uses CPU to run any code. Now, in traditional thread per request model, for each request, Java creates one thread to handle that request, which means if two more user accesses your server at the same time, Java will create two more threads. Now these threads or earlier version of these threads, which are now called as platform threads, are usually associated one-to-one with operating system threads, which means JVM doesn't take care of scheduling of these threads, and these threads act as a thin wrapper around OS thread. So there is a one-to-one mapping between Java threads and operating system threads, which means for these three threads, three OS threads would be created. Now, what is the problem here? So problem is OS threads are expensive. For example, each OS threads is associated with 1 MB fixed stack. And the usual operation on these threads are usually blocking. So if you see the problem here, right? These are expensive OS threads which needs to be created for one request. And usually server requests are blocked. So we are blocking the expensive threads, which creates a problem to scale this to handle more requests. So for example, 10,000 threads would require 10 GB of memory, and it would be impossible to scale more than these. Like we cannot create millions of threads, which is requirement for modern applications. Now let's look at how virtual threads works or how virtual threads solve this problem. So let's compare them with platform thread first. As we have seen, platform threads are created and they are mapped one-to-one to a OS threads. So there is a one-to-one mapping between platform threads and OS threads, and this is the problem. Now let's see how this is solved in virtual thread. Now virtual threads are created in JVM, so they do not have direct link with OS threads, and that is where the magic happens. So because virtual threads are not associated with OS thread, we can create many of them. But how does then virtual thread executes? So for that, what happens is there is a pool is created of platform threads which are directly associated with OS threads. And these threads are called as carrier threads because these threads carries the virtual threads. Now, since virtual threads are not directly linked with OS thread, we can create as many of them without exhausting the OS threads. This here is called as M2N mapping. So there is M2N mapping between virtual threads. This allows us to create as many virtual threads as possible without requiring to create so many OS threads. But you may be wondering, what about the blocking? Now virtual thread while executing on carrier thread still can get blocked, right? Yes, that is still a problem, but let's see how that is solved by virtual threads. And that brings us to important concept in virtual thread, which is mounting and unmounting. So this is where all magic happens. So let's again draw our three-layer diagram. As you have seen, virtual thread is not directly linked with OS threads and it executes via something called as a carrier thread. And this allows us to create as many virtual threads as possible. Now let's take an example of one virtual thread and see what happens in its lifetime. So virtual thread, when it is created, it is inside a JVM. But when it tries to execute or it wants to run, it is mounted on a carrier thread. So it gets mounted on carrier thread and there it executes. So what if this virtual thread gets blocked? And that is the important point here. So when the virtual thread is blocked, doesn't remain on carrier thread. What happens is it gets unmounted and parked. This is called as a unmounted or parked status. So where virtual thread is not there on carrier thread. And during this time, another virtual thread can get mounted on carrier thread and it can execute and complete its operation. Then it will get unmounted, and when the IO operation because of which the virtual thread was blocked, which is completed, virtual thread can get again mounted on carrier thread. And this allows JVM to create as many virtual threads as possible. It can create millions of virtual threads to handle millions of requests. So let's look at now code and see how we can create this virtual thread in Java. Now let's look at how we can create a virtual thread in Java. So there are three ways. First one is a direct way, wherein we can use thread.offVirtual. You can see there are two methods, off virtual and off platform. We can use off virtual for virtual thread. And then we can simply do start and pass it a runnable. So I'm just going to print thread name here with some message, say inside virtual thread, and I'm going to use thread.current thread. Let's try to run this and see. Okay, there is no output here. So okay, so what happened here is like main thread exited before virtual thread could start. So I will just add a join here so that main thread waits for this thread to complete. And let's run it again. Okay, you can see the message is printed and our virtual thread is running. And if you see, this is the carrier thread on which it is running. Now let's see another way to create this thread. We can also do it by using another method in thread.offVirtual of a by using say name. If you want to give some name to this thread, I will call it vt1, and instead of starting it, we can also make it unstarted so that it won't execute immediately. This gives us some fine grained control we can run whenever we want to. Now this would return as a thread object. So let's create a variable to hold this value. Now we need to again join, right? Because it again to make sure main thread doesn't exist. And we also need to start this thread because it is unstarted. We used unstarted function. Let's run it as well. If you don't see, again vt1 is running and it is running on a carrier thread. Let's look at third pattern now, which you should use in production, which is using executor service. Now executor service has a new method now for creating executors for virtual threads. So you just need to provide executors dot new thread per task, virtual thread per task executor. Now this executor service is auto closable. So we should always surround it inside, always put it inside try and catch block. I will simply log some error message here. Now let's create some for loop and create more threads. As we have seen, we can create n number of virtual threads because these are very cheaper to create. Now we need to also remember that virtual threads are usually useful when there is a blocking operation. So if you are using virtual threads for any operation which has IO or some network calls, it would definitely get you scaling. However, for CPU bound operation, it doesn't provide any additional benefit. Now let's use executor service.submit to submit another task. Let's run this as well. If you see, we created 10,000 threads in really no time. And as you can see, it is running on the fork join pull various workers. So there is a pull of carrier thread over which is individual virtual thread is running. Now to summarize, let's understand what we learned so far from this video. So first point that we learned is OS threads are expensive. Hence, if we block the OS thread, it is going to be wasteful and we should avoid that. So how virtual thread solves the problem? So virtual threads are JVM managed and not actually managed by the OS. So there is end-to-end mapping because of we use carrier threads and hence virtual threads can be scalable. Then what we understood is blocking problem is solved by using something called as mounting and unmounting, which leaves carrier threads free and we can scale to million using virtual threads. So this concludes today's video. If you enjoyed and watched so far, please don't forget to subscribe and like the video. If you want to see more such video, please leave comment